objectives of the session is what exactly is Spark, and so what exactly are its capabilities, or probably what exactly it is not, right? So we'll be talking about that. And then after knowing, okay, what exactly is this, we'll talk about why should we even go for Spark, because there are various other systems which are available. What is Spark? Even before this, I would like to, even before covering any specific point about it, I would like to step back. And I would go one step back, and even before talking about what is Spark, I will talk about what is analytics. I mean, what exactly are the different kinds of analytics, right? So when I directly jump to the point of what is Spark, I assume a lot of things. I assume that you people know that big data, you are accumulating such a huge amount of data at such a rapid pace. Very good. For what purpose? You are going to typically use it for the analytics purpose. Okay, analytics. So typically, how many types of analytics are there? There are typically two kinds of analytics. One is the batch analytics, and second one is the real-time analytics. So when it comes to the batch analytics is probably kind of reports which you generate and which run at a specific frequency. That frequency could be once in a month, every day, every 1 hour, whatever. Right, so that is typically a batch analytics kind of a mode, and Hadoop is kind of best possible answer for that kind of requirement. But then there comes the second kind of requirement, wherein you are going to talk about the real-time analytics. Now this real-time analytics is something which is quite challenging, which I would say is the bread earner for many of the companies which are working today on real-time analytics. So the typical example for that might be as simple as a bank. So you are doing a POS transaction, right? You are let's say swiping your credit card. Now there are two ways of looking at this transaction. There are two ways. One is a traditional way, right? So the traditional way of looking at the transaction is you are doing it. You kind of store the information. Let's say what is the customer ID, what exactly was the amount which has been transacted, whether it was a valid one or not, and so on and so forth. Now this is a traditional world where if you apply some certain checks and balances, if it is good, you are going to approve it and you are going to save it. Now let's tilt the situation a bit, and let's say you are going to have some sort of, now you're applying any kind of a big data solution and all, and wherein you are able to capture further more information. So typically, let's say I have started capturing in the geolocation. So latitude, longitude of the place from where the transaction has started, right? So just the moment I start doing this, then I'm going to have extra information. Very good. Now let us say from a specific credit card, 2 transactions have happened. One transaction is happening right now. Everything looks good. Another transaction is happening half an hour later. Again, everything looks good. Everything is within limit. There are proper codes, there are proper authorizations which were provided, but there seems to be a bit irregularity. If I see, let's say the first transaction is happening in Mumbai, India, okay, and half an hour later I can see there is another transaction which is originating from, let's say, somewhere in Delhi, New Delhi. Now with the geolocation, so everything apart from geolocations is good. But the geolocations are suggesting that within half an hour, if something is happening at these two complete disparate geographical locations, this might be an indication of a fraud transaction. Isn't it? Isn't it? In the banking terms, in a typical kind of a scenario, these two transactions don't raise any suspicion, right? But when you combine it with the extra information, whatever you are gathering, right, you are kind of getting overall different geographic locations altogether, right? And now the point is, if you are doing this check, you have to do this check when the transaction is happening. you cannot really do this check as soon as the transaction is passed through, or as soon as the payment has been done, because after that the damage, whatever had to happen, has already happened. You cannot stop it, right? So that analytics of the transaction has to happen when this particular thing was happening. This is just one example, guys. This is just one example here. There are so many examples which can be used. So now the point is, you cannot really know whether the first transaction was a fraud or the second transaction was a fraud, but definitely something has happened. So if you apply some sort of real-time analytics kind of solution on it, there is a bank which has already implemented. I was kind of helping them with it. I cannot really reveal the name of that bank right now, but yes. So due to this, what happens is, if they find this kind of disparity, you will immediately get a call. So this is kind of a referral system. Rather than directing it to the payment gateway, probably it would be directed to a referral team, which will immediately call back the registered mobile number. They will confirm that there is a transaction at so and so place, and the other transaction is happening at so and so place. What do you think, right? And if the customer kind of identifies it with some sort of specific security questions and all, then they allow the transaction to go on. Otherwise, it is kind of cancelled, or it is kind of blocked. Isn't it one of the biggest examples? Of course, there are various kind of you can put various ifs and buts. What if I'm sending it via VPN, via US networks? Of course, there would be a lot of other things about it. But yes, the point is, you have taken a right step at the right time, right? The idea of this example was to show you the importance of real-time analytics. Now I'll come back to Spark. So when it comes to the real-time analytics or near real-time kind of analytics, there are various solutions which are available. When it comes to this, then typically, I don't know if somebody has already attended the course on Storm. So Storm is another kind of a framework which typically, reads the streaming data, and then it keeps on performing calculations on that. It's a different model of performance. That is one. Spark is another one. Spark is more tightly integrated with Yarn, okay, or I would, rather than saying Yarn, with Hadoop. This actually comes from the family of it. So Spark, what exactly it is? Spark actually is a general purpose, and it's a in-memory computing system, and that too it's in a distributed manner. So if I put them together, it's basically a cluster in-memory computing system overall. So here, all of the calculations, whatever business logic has to happen, instead of happening it on the disk, it is going to happen in memory. And then there are several ways of caching the results and all, and then there are some refresh rates and all those stuff. These things do happen, but yes, it's all about that in-memory operations, as well as holding the results also in memory. That is point one. Second, it is so Spark is typically written in Scala. Nearly all of its source code is in Scala. So that's the reason you can easily see that there is a handle of Scala in it. But yes, having said that, Spark provides the APIs for Java as well as Python also right now. As of now, these three languages are supported: Java, Python, and Scala. However, for the obvious reasons, our entire coverage is going to be based on Scala, not on Java. Because one, Java is quite verbose. Second, Scala is much more beautiful. This is though it is my personal view, but still, that's how it is, and that's how it goes. Now, also, so this is one point. But is this the only thing which makes Spark very, very powerful or very, very popular? No. There are various high-level tools also which have been built very, very rapidly on the top of Spark. So there is something called Spark SQL. Sometimes people call it as Shark. There is something called MLlib, which is a kind of a machine learning library which is built on the top of Hadoop. So you can actually kind of correlate them to your Hadoop framework, wherein you typically talk about SQLs and all. Then you start thinking in the direction of Hive. Yes, you are correct when it comes to Hive, right? In Spark SQL, you can run all of your Hive queries as it is, unmodified, no syntax change. That is something which is the biggest gain. From the programmer's, effort perspective, from a performance perspective, in some scenarios, personally, even I also have seen that, the Hive queries run around 100 times faster. It is almost 100 times faster. So from the performance as well as development perspective, there is a huge, there are huge savings which are involved with it. So when it comes to Spark, of course, if I have to kind of, recapitulate it, it's all about you get high-level APIs, you get high-level tools, and there are some more things which I'm going to cover now. Also, so when I cover it about what exactly is Spark, before I cover why Spark, there are kind of some interesting comments. So I believe Scala or Python is preferred over Java in Spark. Yes, definitely it is preferred over Java, because you can easily understand it, right? That it is all about, so when it comes to Hadoop, you prefer Java. The reason being, it is written in Java. So there are some native dependencies and all which can easily be taken over. And of course, there is a bit of performance improvement. But however, those people who have worked in Scala at any point of time, they know that Java and Scala are interoperable. You can call Java programs from Scala and vice versa, right? So typically people call Scala as improved Java. And as probably Karthik, and there are some more people who are saying that how about Java 8? Definitely Java 8 is kind of trying to imitate Scala and nothing else. So there are some good things which are happening in Java 8, definitely. But the answer is you try Java 8, but the problem is, guys, one thing is for learning, right? Another thing is for the implementation in production. So typically those organizations and all, they have their environments already set up. So moving from Java 7 to Java 8, probably there are so many organizations which are not even working on Java 7 as of now. You're talking at Java 8 level, right? Which is brought in the concepts of lambdas and all other stuff, right? So it will be a big decision. So it completely depends upon the kind of setup in which you are going to work, right? Karthik, others, right? So GC is asking about a kind of question wherein for real-time analytics, how to decide whether we should go for Storm or Spark. It's a very detailed discussion, GC. If I start answering that and the factors about it, probably it's going to be quite long. But yes, it's an interesting thing. You can follow some of the Edureka blogs about it. We'll definitely be putting something about it there. Now, after knowing what exactly is a Spark, when it comes to why Spark, right? So with Spark, you get a lot of flexibility. When I talk about flexibility, typically you go to any other, any presentation, be it Hadoop, be it Spark, be it Storm, you'll always see there is flexibility, and it's kind of their USP. It is no different with Spark as well. But the good thing is it provides you those options, right? One option is, hey, I want to just run my Spark cluster. I have Spark provides its own cluster manager, though it will be a admin kind of track, but still it will provide you a cluster manager wherein you can use its inbuilt cluster manager and go ahead with it. It would be a pure simple machines and no Hadoop, nothing running on the top of it. Very good. There is something called Mesos, Apache Mesos, right? This is something which is a kind of another cluster manager, which is again does a similar kind of a things, but it is specifically designed only for cluster management. So you can deploy Spark using Apache Mesos as well. At the same time, you can you can run Spark on Hadoop cluster on the data which is there is staying in HDFS. So there are ways. So early that becomes the USP for Spark, that it is easily integrable with Hadoop. Now, I don't know if anybody has attended Storm classes or not, but when I took Storm classes, I used to get a lot of queries on that. Can't we integrate Storm with Yarn? And at that point of time, I told also, if you remember, that this is a WIP, work in progress kind of a thing. There is already a project which is going on, but it still is not completed. This is where Spark gains the edge over Storm, wherein it comes pre-integrated kind of thing. So if you talk about CDH5, Cloudera distribution of Hadoop 5, or you talk about HTTP, Hortonworks distribution, take any of these distribution, I think version 2.0 plus, they are providing Spark integrated. So the integration effort and other stuff are already taken care of. And with this, the good thing is you get the reliability of Hadoop as well as the speed of Spark. So it is all about the best of both of the worlds, which are which come together. So from the deployment perspective, it is you can deploy it in 3 different modes. That is another good thing. It gives you immense flexibility in the terms of the kind of implementation, whatever you want for, let's say, for your organization or for a specific client altogether. So by the way, we'll be covering like deployment using basically on Spark standalone as well as on Yarn also. So it would be a pretty simple thing. In course, we'll be covering that. Now, just continuing on the same thing, I think I have covered already this point, kind of at some earlier slide itself, wherein when it comes to why Spark, Spark framework is all about, it's polyglot, can be programmed in several programming languages. When I talk about in several programming languages, apart from Scala, Java and Python, nothing else is supported as of now, but it is like WIP. So probably, I don't know, some months down the line when you will see again this slide, probably you will see some more. You'll see some more options available to you. But as of now, it is going to be Scala, it is going to be Java and Python. Probably when I'll show you some of the examples in the class, so the first batch, I think I'm going to take the first batch. At that point of time, when I would be dealing with some REPL thing, at that point of time I would be showing some of the most of my examples using Scala, some of the examples using Python, and probably 1 or 2 examples which I have kept for Java as well. But for all, I think once I move away from REPL, when I go back to my actual codes and all, right, they would be typically in Scala only, for the very obvious reason, right, that because of the compatibility thing. Now, the same discussion continues when Hive. So typically, people have seen a lot of potential that Spark does the processing in memory, and Hive, specifically those guys who are data analysts and all, they were very good with Hive. They said, we are able to explore the things very fast, which are there in SDFS, but not fast enough. Okay, Hive definitely hides the complexity of Hadoop from you. Definitely it hides. But the trade back is, or the trade-off here is that you are kind of going to get the answers in the orders of minutes, not in sub-seconds or seconds, right? So that was the problem with it. So once you combine Spark, okay, Spark along with the Hive, it is called Shark. So this is typically the word which it uses, and in some cases, I think I have talked about it. I have seen it performing almost 100 times faster. In fact, I'll show you. What is the what is the hello world of big data world? What is the hello world of big data? Hello world program, I would say. Word count, right? Right. You will see word count today also. You'll see the same word count, and then so I'm sure all those people who have typed word count, right? You must have attended Hadoop class, and you must have seen that typically you get some 10 or 15 words, right? 10 or 15 words, and then when you process it, it definitely takes easily more than 30 seconds or 35 seconds, right, guys? I hope at least those people who have started it, right? Now you will see what happens today. I will run one program for you, the same word count at the end of it, right? You'll see it today, right? So 100 times faster than MapReduce or 100 times faster than Hive, you can assume it as kind of interchangeable thing, Anil. Okay, so when you talk about Hive, yes, it is faster. We are comparing it with MapReduce, underlying MapReduce operations, right? Now, so let me just continue on something which is even more exciting. Okay, it's kind of recapitulation. So the good thing is that you know, okay, just a second before I proceed, right? Before I proceed, there is one more important thing. So Shark, I have told you some of the advantages of Spark. There's another thing which is work in progress, which is not mentioned in this slide, but like with some of my friends who are already into this development, they are telling me about it. So just like Hive, you people would have heard about Pig, right? Pig. And people were working on with Pig. Basically, you were able to express your data flows much faster, much easier, right? Now, when it comes to, there are some efforts which are going on. They are not even in alpha release. They are still in development stage, guys. Okay, there are people who are trying to integrate Spark with Pig. Now, this is interesting. This is very, very interesting. Assume that the same Pig scripts, whatever you are running, start running 100 times faster. Isn't it a kind of a dream come true kind of a thing? At least to me it is. And that project, somehow I know that project. The name of the project is Spark, S-P-O-R-K, Spark. Okay, so it is, I don't know whether the project name will change over the period of time, but it is something like an internal project name as of now is called Spark. So let's see when it comes back, but yes, some exciting things are happening overall. So why Spark? So again, continuing the same discussion, wherein it provides you, caching as well as disk persistence capabilities. So you can perform some of the calculations. You can either keep them cached in memory, or just in case if the data is big enough, there might be some of the spells also which may happen, which you may allow. So there are various options which Spark provides you: memory only, memory and disk only. There are several caching capabilities which Spark provides you. The other good thing, which is really, really good about Spark, is it allows you interactive data analysis. When I talk about interactive data analysis, you talk about Pig, you talk about MapReduce. Okay, I'll not talk about Hive right now, but let's say talk about these two. You cannot really work interactively. You do not really have an interactive shell. With Pig, there is something called grunt. Yes, it is. But again, it is not purely interactive. But when it comes to Spark, it is kind of, it provides you REPL, right? Read, evaluate, process, and what is that? Load kind of thing, right? So this provides you that typical REPL feeling, and you can, write your commands, evaluate them then and there, and then see if they are working. And so, kind of easily interactive data analytics is something which is provided by it. Faster batch, no need to tell about it. Iterative algorithms. The biggest pain point for Hadoop is you cannot really support iterative iterative algorithms. So if you cannot really support it, so recursions, for example, right? Recursions and all are not supported there. But when it comes to Spark, yes, you can. Of course, there are ways, there are some tricks through which you can support it, but still. Okay. And third, last but not the least, so of course it is the, the outcome of first few 4 or 5 points, that all of those points combined together, they typically lead for, faster decision making altogether. So these are some of the USPs of Spark, which I would like to say. Now, this is something which is straightforward. Okay, this is kind of a straightforward lift from GitHub. This is not from, this thing is not from Google Analytics. This is from GitHub. You can see the commits to, the masters of master branch of Spark. So you can see this around October of 2013, and then 2014 start, and still it is going on, right? There is huge traction in the number of commits which are happening, and the community is super active. There is one thing is called active, there is something called super active. By the way, another important thing, Spark got introduced to Apache community later than Storm. Okay, Storm is an incubator project. Spark has become a top level project. Spark has become a top level project. It is the first project, or I would say the project which has achieved the top level status in the record time. So this is another the kind of exciting thing which is coming up, and there are already companies like Uyala, you talk about, I mean there are several others which are already using Spark and Storm parallelly in their production systems. So I mean data speaks for itself, so rather than talking much about it, I will leave it to your analysis itself.